Chain rule. Chain rule. That's the sound of the man working on the chain.
What?
Yeah. Both songs from Miles Wilbur. Chain rule. Chain rule is a way of differentiating not products, not quotients, but composite functions. So if something's a composition of two functions, you'd want to apply chain rule to it. And it gets a little bit hairy sometimes because people don't necessarily grasp the idea of a composite function the way they grasp the idea of like, well, that's clearly a product because it's two things being multiplied, or that's clearly a quotient because there's a big old fraction bar. Kind of a tip-off. Sometimes you have to use, and just like with quotient rules, sometimes we had to use like product rule within the quotient rule, you know, that kind of thing. Sometimes we'll have to use product or the quotient rule within chain rule. It can happen. It's before we get to actually how chain rule works, let's just review a little bit of what a composite function is and how it works. Say we got f of x equals quantity x squared plus x, and that whole thing's being squared. That would be a composite function. A composite function has like one function going to a power, or it's the square root of a function. It's going to have what they call an inner and an outer part to it. On this one, the so-called inner function inner function would be what's in the parentheses, the x squared plus x. That is what is being sent to a power. So we think of that as the inner function. The outer function is what, it's kind of like the verb in the sentence. What's that doing to the inner function? Well, what is being done to the inner function? It's being squared. So your outer function is x squared. And working together as a composite function, you would take the inner function and plug it in for x in the outer function. As a result, you would get not x squared, but x squared plus x squared, which is where this comes from. So it's going to help to be able to see, in a bigger picture like a composite function, it's going to help to be able to see what's happening to what, and identifying the inner and the outer function. Let's maybe try another one. Let's take if f of x is square root of sine x, this is a composite function. It's going to have an inner and an outer function. I'll call the inner function I of x, just instead of writing inner every single time. Sine x is going to be the inner function. That's kind of the subject in the sentence. That's what's having the action done to it. the verb in the sentence, the outer function, is whatever is being done to the inner function. Well, what's being done to the inner function? Square root of it. So your outer function is square root of, and we just use x, because sine x would be plugged in for just x in a composition. As a result, you would have square root of sine x, which is exactly what you're supposed to have. So a lot of this is just breaking down the pieces. This isn't shocking you,
No,
is
no.
it?
Could you put x to the
No,
1 half?
sorry.
I'm sorry?
Can you put x to the 1 half?
You could. And in fact, that's what we're going to want to do ultimately, because that'll work really well with power rule. How about g of x is cosine of quantity x squared plus 4. Your inner function here, what's the function that's having something done to it? Yeah, the x squared plus 4 is what's being operated upon. The outer function is the operation that you're doing to it. What are you doing to x squared plus 4? The cosine of it. So yeah, cosine x.
What is going on?
Sounds like they're fighting. Oh, I took that class yesterday. I passed.
How about if you've got 1 minus 4x all going to the 3/2 power? That's a composite function. You've got an inner function that's having something done to it. What would you suspect your inner function would be here? Yeah, the 1 minus 4x. And then the outer function, what's being done to that 1 minus 4x? X to the 3/2 power. I'm going to tell you up front, this next one's a trick one. You ready? We got y equals x sine x. What's your inner function?
It's not an x.
It's not a composite function. I am. It's not a composite function, it's a what? I thought you were going to say it, and then you went to multiply, which is true. Oh, it's a product. It's a product. It's x times sine x. It's a function times a function. It's not one function being plugged into another. It's a product.
I was just holding it.